Let's keep all of this going. We can find the derivatives of these things. In the last video, I did the trig functions and that first one with the power rule. But we could do more. What about this guy here? An e to the x? We like e to the x. That's usually pretty easy. So let's write it like this. F of x equals 2 minus e to the x to the 1/2. That's what a square root is, isn't it? Yes, it is. It doesn't look much like a 1/2. So ugly, I'm going to rewrite that exponent. I'm feeling OCD today. So the chain rule says, take the candy shell, do its derivative alone with the original input, and then multiply by the derivative of the input, the chocolate on the inside. So that means the first part is to do f prime, which says this. Put the original right in there. That's our inside function, g of x. And then multiply by its derivative. Well, what's the derivative of this? We know that numbers fall off, so we're taking the derivative of negative e to the x, which is negative e to the x. So we should get negative e to the x over 2 root 2 minus e to the x. Problem solved. Next one. Now see, that isn't so bad, is it? Just takes a little practice with the chain rule. Insides and outsides. How about the next one? Looks a lot like that. Let's try it. 1 plus 4x. And a cube root is to the 1/3. So the outside function again is our root. So we'll take the derivative with a power rule. 1/3. 1 plus 4x to the negative 2/3. Just subtracted 1. And then multiply by the derivative of the inside, which is 4. So you get 4/3 over here, and this is gone. And this is our answer. That was the easiest one yet. You just whip that through. Thank you, chain rule. What else have we got? Maybe there's something tougher in here. What about e to the root x? Because that's e to the x to the 1/2. And that's not the same as e to the x. So we have to do the chain rule. And I think you can guess where we're going with this. What's the derivative of the outside? That's the e function. So that's e to the x to the 1/2 times the derivative of the inside, which is 1/2 x to the negative 1/2. You able to see that? So how do we write that? That would be e to the x to the 1/2 over 2 root x. And then we can replace this if you want like this. Pretty easy. Still pretty easy. Maybe we can find a harder one in here. This one looks like a power rule. Well, we can put it in real quick. X to the 4th plus 3x squared minus 2 to the 5th. Take the derivative. Outside function is the whole thing, the 5th part. So it'd be 5 something to the 4th. Well, the original function is x to the 4th plus 3x squared minus 2. Nothing changes there. Then we multiply by the derivative of the inside, 4x cubed plus 6x. And that's it there. All right, we could distribute that 5 in if you want. We could take an x out if you want. How about we write it like this? 5x times 4x squared plus 6. You want to take a 2 out of it before I finish this whole thing up? Let's do it. Let's make it 10x times 2x squared plus 3 times x to the 4th plus 3x squared minus 2. And that would be the answer to this one. No big deal, really. Just take some practice using these outside functions and then your basic algebra, which you thought you passed with flying colors years ago. You're now realizing that's not the case. 1 minus 2x to the 1/2 for this problem here, take the derivative. The outside function's the power, so we write 1/2. The original function inside minus 1/2 times the derivative of the inside. Well, the 1 falls away. So you have minus 2x. That becomes minus 2. And these will cancel, won't they? I think they do. So we're going to get negative 1 over the square root of 1 minus 2x. That should be the answer for that one. You see how quickly you can whip through these and you just do a little basic algebraic notation. And finally, we get one that's different than the others. This is going to be some kind of a special moment here. But I'm going to write it a different way. F of z equals 1 over z squared plus 1. Looks kind of like a messed up 7. Let's write it this way instead. I can do that. That's allowed. So let's take the derivative. That would be negative 1 to the minus 2, and put the original back in, times the derivative of the inside. Well, that would be 2z, wouldn't it? So your answer is going to be negative 2z over z squared plus 1 squared. That's the answer. So this will whip through this problem set, but in the next video I'm going to add some complexity to it. So make sure you can rip through these. They're not supposed to be hard.